Okay, you may begin.
Hey, good morning. My name is Kelly Halpin, and I am a computer science team and math resource teacher with the math office. And I am so excited to be talking to you today about how to engage your students in mathematics at home. Thank you so much for being here. And I'll also allow Spencer to introduce himself as he'll be supporting in the chat.
Good morning. You won't be seeing me. I'll be the voice from the sky. My name is Spencer Jameson, and I will be supporting Ms. Halpin today. Um, I have a great job. I am the elementary math specialist on the math team for Fairfax County Public Schools.
I do
All
want to
right.
jump in for a moment. This is Shannon again, just let you all know that the webinar will be recorded and the link in the presentation slides will be sent to you out to you next week. You can type in your questions in the chat, and Kelly and Spencer will address your questions from the chat. Thank you.
Thank you, Shannon. All right, so let's jump right in. So today we're going to talk about framing positive mathematics identities with your students. We're going to talk about some of the important elementary numeracy concepts. We're going to explore ideas for play and noticing math in the world around us. And we're going to make connections to math in context, whether that be through books or through story problems. We're going to talk about the role that math has in context. Right, so we're going to go ahead and first we're going to talk about those positive math identities. I'll give you a moment to read this quote. So this is just kind of setting the stage that research really shows that when parents and young children take time to explore, enjoy, and talk about math together, it sets the stage for positive early math experiences and helps young children view themselves as those capable mathematics learners, right? So the work that you're doing, the play and the fun that you're having with your students around mathematics really makes a difference in how they view themselves and how they view their role in math as well. So the quote that, or the wordle that you see comes from a professional learning where we asked 50 math coaches across Fairfax County what they want mathematics to be for their students, or what they think mathematics is in their schools for students. Just describe one word of what mathematics is and what the experience they want for students. And this is what they came up with, right? So in this Wordle, the bigger words are the words they typed in more, the smaller words are a little bit less. Take a look at some of these words and think about what's resonating with you. How are these words to describe math similar or different than your experiences? And if you like to, we invite you to capture that in the chat. What connections are you making to this Wordle that math coaches use to describe the experiences that they want for students in elementary school? And how is this similar or different to your experience with math? And Spencer's going to be helping me monitor the chat. So as you're ready, you can take a moment to kind of enter some thoughts. Anyone making any connections to these words in math? How is it similar or different to how you thought about math?
Someone said challenging.
Thank you. I know when I was young, I thought challenging was a bad thing, right? But challenging as in it like pushes them to critically think and persevere and problem solve. Yeah, thanks, Lynn. So maybe it didn't feel fun or creative for you, right? It might have felt a little bit more procedural, where math in elementary now is really fun and enjoyable and creative and seeks multiple ideas and perspectives. Thank you. As a parent, it makes me really excited to see that in our schools, that these are the words that are resonating in math. This is the experience I want for my son.
Yeah, we had another person said empowering.
Yes, empowering, absolutely. Empowering students to feel like they can be problem solvers, like they can do this, absolutely. So sometimes we grow up and we hear people say, I'm just not a math person. It's okay if you can't do math. I can't do math. It's okay, right? I've said that myself. And I've really been changing my mindset more and more with how I'm talking about myself as a mathematician, especially as I've gone from being a student to a teacher. So we really don't hear people say very often, well, I can't do that. I'm not a reader, right? So we don't want to create negative connotations around math, right? That might make people think that you're born being good at math. And that's just not true. I listed on the resources page that Shannon sent out, and will most likely send out again, some research around growth mindset. So we want to promote that everyone is a learner, and it's important to speak about math positively with our students. Not to say that you never struggle, right? You can say, this is really hard for me. I don't understand this yet, but we can do it. We can do this together. I can figure this out, right? So the way you talk about yourself, your student, in the context of math, perhaps makes the biggest difference about how students approach situations and how they feel about themselves as mathematicians. So really creating a positive math identity, and that's something you're going to notice in classrooms as well, is that there's a, like, built into the curriculum, there's a lot around building community and everyone kind of taking on that identity as a mathematician and having different strengths and things to offer, and that everyone can learn math at high levels. So we're kind of just setting the stage here. So I thought this was really interesting. Research suggests that infants can spontaneously remember small objects before any formal education. So you might hear your toddler say, I want one more strawberry, or I cut the sandwich in half, or I have two fingers, or you might hold up a dice and they might recognize that they see four, right? So this actually begins really early, which I think, whoops, I apologize, my screen just went down, which I think is really nice to hear that our kids are mathematizing things so early on. So what is numeracy? What is that when we say numeracy, right? It's the ability to think about math concepts in all areas of life and make those connections. It also involves understanding numbers, counting, solving number problems, measuring, sorting. Oh, patterns are so big, noticing patterns and applying them to all areas of math, and then definitely that computation as well. This is only some of it. There's more included, but that's kind of a general definition or some examples of what numeracy can include. So the two things that we're going to kind of focus on today is that side of early numeracy, and specifically counting, right? When your students are maybe pre-kindergarten, kindergarten, first grade, kind of those early years. And then fluency with addition and subtraction and multiplication and division. These are some of the math ideas, certainly not all of them, but some of them that we're going to talk about today. And Spencer or Lynn, please just stop me in the chat anytime if anyone is contributing and you want to lift anything up. Okay, so when students are first learning about numbers, there's this, we call it 3 aspects of number, right? So they start hearing about the word 3 in their lives. Your brother is 3. You walked up 3 steps. And then they start connecting it to the quantity. You have 3 strawberries on your plate. You're holding up 3 fingers. You counted 3 blocks. And then eventually they start learning that the word 3 and the quantity, the amount of 3, connects to the symbolic number of 3. And when we do this, it sets the stage, right? So when you're making those connections for your students of how does the word connect with the amount, connect with the symbol, it extends all the way to algebra. So when kids are learning to solve these 2-step equations in 7th grade, they're still doing the same big idea and connecting the verbal to the quantity or the model to the symbolic, or here the equation. And I just think it's so special that we're setting the foundation for algebra in those early grades, and it's all connected. So these 3 aspects of number is something that's important, that's going to kind of carry us all the way up. That's really important. And I'm just sharing these big math concepts with you so you can kind of be aware of like, what might be important as I'm noticing and wondering and pulling things out for my student in the real world around them. So when we think about early numeracy, right, you might hear your students count when they're younger. 1, 2, 3, 4, 5, right? That's rote counting. And you also might hear like they can count, but maybe they're not attaching a meaning to every number. They're not connecting the number they're saying with an object yet. And that's one-to-one correspondence. We'll be developing in kindergarten, sometimes before that. But that takes a little bit more time for students to develop, and students really develop that when they count, push, move objects. And again, Spencer or Lynn, please add on to anything that I'm saying. I invite you to kind of lift your voices into the room. We have so many experts in here as well. So in early numeracy, we're really, one thing we can think about is counting and the difference between saying the numbers, which is still great, right? But maybe working eventually from that route counting to that one-to-one correspondence where I'm saying a number and I'm moving an object and I'm able to kind of count and keep track of my count. So that's kind of early numeracy, but what is fluency when we say that, right? With multiplication and division facts. When I was younger, I heard a lot of memorization, right? You need to know your facts. I got the flashcards, I got the anxiety from 3 times 4. What's the answer, right? We kind of approach fluency across the state and then Fairfax County a little bit differently now, right? So I'm going to give you a moment to read the quote and then we'll talk about it together. Can you put a word in the chat that might be resonating with you when you read this description of fluency? Relevant. Oh, thank you. Something that stood out to me was like patterns and relationships. When we look for patterns and relationships with numbers and we gain a deeper understanding, it brings more meaning. So we're not just memorizing the facts, but we actually understand what they mean. Thank you so much, Judy. That it's everywhere, right? That we can really see those numbers, relationships, and patterns everywhere around us. So when we think about that, right? When we think about this approach to fluency, it's really about developing flexible strategies depending on the numbers, strategic, Am I using a strategy that makes sense for the numbers? And is it efficient, or is it a fast way or efficient way for me to solve the problem, right? And eventually students get to recall. So if I'm giving them a basic fact, they'll eventually get to mastery and knowing what it is, but that there's some foundations and some steps in between there. So let's take a look at what fluency actually looks like, and or what an example can be. So how does it develop? Well, in the primary grades, if students are given an image like this dot image, you might hear them counting 6, 7, 8, 9, 10, 11. Or you might hear them counting all of the dots 1, 2, 3, 4, 5, 6, right? So students will start with that counting. And then you might hear them develop or derive a reasoning strategy. I know that 6 plus 4 is 10 and one more is 11. So they might make a 10 or use a double, right? They're really starting to look at the relationships between numbers. They're starting to make groups of 10, to double, to think about what they know about the numbers. And eventually they will know, oh, okay, 6 plus 5 is 11. However, the idea of counting and using those strategies, deriving those strategies, are so important before they get to that mastery stage. So we don't want to just kind of, again, how I learned it is like, here's the flashcard, tell me the answer. And I actually memorized facts wrong. For the longest time, I memorized 6 times 7 is 43. And that's just what I thought as an adult, right? And so memorizing is something we need to hold in our brain instead of something that we understand. So that's why it's really important to kind of, in school, that we address the things that come in between. And as parents, you can do that too. How do you see the image? Are you counting? Are you making 10? Are you seeing a double? The same idea applies to multiplication facts. So you might give them this real world image of an array, and you might hear kids count. They might count 1, 2, 3, 4. They might do that, or they might even skip count. Oh, okay, I see 4, 8, 12, 16. Those are great. They're starting to discover patterns and relationships. Eventually, they might say, if I just split that array in half, I see 4 groups of 3 over here and 4 groups of 3 over here. And if I know 4 times 3, I can double that, right? How amazing that we're teaching our kids to think flexibly and efficiently, and that this is going to help them as they get older and they start thinking about algebra. And eventually, kids will recognize the facts that 4 times 6 is 24, but it takes a little bit of time to get there. And so this is the basic progression that as your students are building fluency, that they will kind of experience and go through. Spencer, is there anything you might want to add to what I'm saying? Anything I might have missed?
No, so I think the big thing here, Kelly, is for people to think about is kids should have the ability to kind of move in and out of what they know and build on the mathematics that they know. So they're building on the mathematics that they know. And someone actually in the earlier said interconnectedness when they were talking about learning math. And the more we can help kids connect math together, the better they'll be in mathematics.
Absolutely. Thank you so much, Spencer. And that's important too. Like your students might be really flexible with their 5 facts and 6 facts, but when it gets to 9 facts, they might go back to that counting. They might need to develop those reasoning strategies. So it's fluid. They move in and out and just kind of meeting them where they are and trying to make connections into what they're saying and in that interconnected piece. Thank you so much. All right. Let's keep going. So what are the tools that your students will see in school and that you can use at home to build fluency, right? In the younger grades, one of the best tools to use are your fingers. And what you can ask students to do is, can you show me 6? Can you show me another way to make 6? And now you're really getting to those combinations. You're helping them see groups of numbers. You can even have them behind their heads. Can you show, like a bunny ear game, can you show me 5? Can you show me another way to make 5? So fingers are tools, right? Our fingers naturally come, one hand has 5, two hands have 10. Those are the most important numbers, getting to that friendly number of 5 and 10 in the primary grades, right? You also might notice your students have 10 frames. 10 frames are really powerful, again, for making that 10 and seeing numbers structured and organized in a way that helps them to see relationships. You also might see your students have a hundreds chart, which can help them count, find patterns, learn that sequential order, and find relationships as they're counting, and relationships within the numbers and what happens every time we reach a new decade. So these tools are tools that you can use at home, that your students will use at school. A dice is so powerful because it's already grouped. Students are learning to see, oh, okay, that's 6, that's 5, right? Learning to see and recognize numbers helps them to kind of structure and recognize and apply it at other places. Even counting bears, just counting and grouping is so powerful. And again, I invite Spencer, Lynn, anyone else to kind of, or actually, I'm sorry, Lynn, you might not have voice control, but Spencer, or to kind of jump in, or anything that I might not be including.
So I'm just going to put my voice back into the room. And
Yes,
one of the things
please.
I want to talk about is when we're building fluency, the good thing is, you know, you might have heard of new math and those types of things. There's really, math is the same. We want, math is the way that we look at life, and we make it into, you know, numbers, and think about how can we make those numbers together. And really our focus is on student understanding versus this idea of this is just the answer. Is the answer important? Absolutely. We want the answer to be important, but we also want the idea that the math that we're doing makes sense. And when we can make sense of it, we understand it better. And that way kids can really think about the math that they're learning.
Thank you, Spencer. Well said. It's nice to have my colleagues like jump in with me, and it kind of, we get so passionate about it, as you can see. So please continue jumping in. Please continue writing in the chat. In the upper grades, right, when students are learning about multiplication and division, tools are still really important. So you even grid paper, where kids can draw and visualize an array, a hundreds chart, where when kids are skip counting by 3s, they're going to start seeing all these really cool patterns visually on the hundreds chart, or numerically they might see patterns. When you're doing, you know, when you're asking kids about a multiplication factor, when kids are a little bit older in 4th or 5th grade and 6th grade even, you know, again, we used to just see the flashcard, tell me the answer, tell me the answer. Included in your resources sheet are some math cards from Joe Bowler that actually connect a visual with the answer and with the product and the problem to, again, deepen that understanding and help to connect various math representations. So these are tools that we might use to build fluency. And we so far have talked about some of the important math skills that your students are learning about and that you can support at home. And now we're going to talk about, like, what does that look like? Now that we know the concepts, now that we know the tools that kids might use, like, what does that actually look like? So we're going to talk about that a little bit. Playing with your students around mathematics is so powerful to developing a positive math identity and to developing confidence, right? So play in the younger grades might offer students opportunities for non-routine problems and to make connections to math ideas. It's related to experiences with materials that develop creativity and perseverance. Your role as a caregiver is really to explore, to take advantage of what kids are already noticing, to ask them questions, and to model yourself. What does perseverance look like? And how can I approach something with optimism and curiosity when I'm exploring the world around me and how math is connected? So we're going to talk a little bit about some examples of what that can look like. So for example, if you have a younger student, you know, and you have a kindergartner and you are playing and blocks with them, you are working with shapes, talking to them about the kind of shapes. What happens when I put these two shapes together? What do you think will happen? Or how tall do you think we can build this, right? So just something simple like that, where you're talking about color or you're even sorting shapes or talking about when I put these two together, what do you think will happen, right? That's an idea for primary. Another idea is Play-Doh. If you're exploring Play-Doh with your kids, you can compare, who has the longest shape? Who has the shortest shape or stick? How many pieces do you have with your Play-Doh? How many pieces do I have? How can I count that? And then patterns. So acknowledging, you know, what you just made as a pattern, blue, blue, green, green. How could you extend that pattern? What would that look like? Right? So just in the materials the kids naturally play with, asking some questions to bring out the math is so powerful and fun, honestly. This is one of my favorite things to do, and this is applicable K through sixth grade. It's called a counting collection. So let's say you have a big group of things at your house. My friend Wendy was carving a pumpkin and used all the pumpkin seeds and asked her children like about how many do you think there are? And just the estimation skills and magnitude, again, so powerful. Just asking, how many seeds do you think are here? Let's count. How many do we actually have? And if kids are counting, if you're doing this in the upper grades and they're counting a large quantity, you might say, gosh, those are a lot of popsicle sticks. How are we going to organize our thinking? Or what groups are we going to make? And they might say, oh, we should make groups of 10. Okay, great. How are you going to keep track of that? How are you going to count? Are you going to count by tens in the leftovers? Are you going to count by something different? So just with counting a collection of objects and estimating and then counting, you're kind of teaching your students about place value and how grouping numbers works and how to keep track of those groups and about quantities and magnitude, something really simple. And you don't need to go out and buy new materials. You can use popsicle sticks or cups, or you can make tens frames with your students, right? So it's about using what you have around you to kind of create these like playful learning opportunities. If you have any questions about what we're talking about or you want us to expand, I invite you to type in the chat. So then we have some math games that help kids make connections to numbers between 1 and 10, numbers between 1 and 5, because those benchmark numbers of 5 and 10 are really important in the world around us. And so you're going to see these games linked on your resources handout that that Dr. Anderson is going to send. How powerful are board games even, right? So when your student is rolling a dice and they need to go ahead, you might say, how can you move ahead 6 spaces? Do you need to count it out? Can you make a jump of 3 and another 3? How are you going to do that, right? So board games are really powerful, again, for developing that strategy and numeracy. Matching games really starts to help kids think about like, how are they going to sort? What does that mean? How are they differentiating the characteristics? Card and dice games, so important for that number recognition, important for a number of reasons, right? Again, like helping them to understand the quantity of 5 and 10 and how they can use those numbers and understanding and applying it to other numbers. So the games you're already playing with students are so powerful. I think it's just about the kind of questions that you're asking. I'm going to pause again and ask if anyone else wants to kind of jump in the chat, ask any questions, make any connections. Okay, please feel free to jump in at any time with a question or connection that you're making.
So I do want to talk a little bit about games while you guys are thinking a little bit. The
Yeah.
big thing about games is that it's real important that you talk about the math too. And you say, hey, there's math in this game because kids just think they're playing games when they're doing it, right? And we know as adults that there are a lot of math that's happening. But if you bring that point out and say, hey, where do you think there's math? And that's a question I use a lot with my own children. Where's math in this game? And have them tell you where the math is, and then you can talk about the math, and that brings that to light while they're having fun doing it. So that's a part I wanted to highlight.
Yes, thank you so much, Spencer. Absolutely. Asking kids, you can put a lot of it on kids too, and asking them those questions because math in math class is really student centered and asking kids the questions. And so putting it back on them and having them identify it is really powerful. Thank you. All right. So games and play can be really fun. And there's also games to play that you can play as a family that directly supports, for example, fluency. I hear a lot of parents say, like, how can I support my students in understanding their basic facts? Well, there are some games that your students might be seeing in their classrooms that you can play with them. You'll see like the how close to 100 is really visual. So it's rolling the dice and making an array. If I have a 1 and a 3, 1 times 3 is 3. How would I do that? Would I make an array going vertically or horizontally? Or what do you think makes sense for the game board? Right. So we included these resources again, linked right to your handout, completely free. We wanted to make sure that everything was accessible and easy to use. There are more games to support fluency included on there as well, but just wanted to highlight a couple and how just playing games and asking your students questions. What do you know about that number? How big do you think your rectangle is going to look? Is that the only way you could draw it, right? And I included some questions on that handout as well, just to kind of spark curiosity as you're talking to students. U Cubed is a really powerful website. It's by a professor that supported it along with other people called Joe Bowler. And U Cubed actually has, and I included again the website link on that handout, many activities, and it will say, 3 through 5, 8 through 10, whatever that grade level might include. And it has some really fun visual games, activities, videos, things to talk about your students. So I saw that some parents had questions about that, like what is a website that kind of aligns and is quality, and I definitely recommend U Cubed. And specifically, I linked on the resource handout where families can go to get some resources. So in addition to just engaging in play with your students, engaging in games, we can look at the images around us in the real world. Arrays are so powerful for talking about multiplication and division and how they're related. So even just creating an array out of your pretzels, how many do you see? How do you see them? Right? Kids might count, they might group, they might say, I saw 3 times 3. Okay. Or they might say, I saw 3 groups of 3. Okay, what would that look like if you wrote that using a number sentence or just talking to them about how many do you see and how can you figure that out without having to count by ones? If they still do, it's okay, right? But trying to get to that idea of grouping and making connections to the real world and multiplication and division. So that's just noticing kind of in your world what you can do. So we shared a lot of ideas at this point. The next thing we're going to do is kind of talk about math in the real world a little bit more and how we can be looking out for it and leveraging it with our students. But I am just going to give us a moment to pause and reflect and invite you to make any connections, or can you share like a new idea you've heard that you might try? There's something that's new to you.
So Kelly, in the chat, we have a couple questions, I'm going to put out there while people are thinking about what connections they're making, and feel free to continue to add to the chat. Um, Someone asked about how do we get teenagers interested in doing math homework, right? Um, and I think one of the things when it comes to homework is that homework should be it shouldn't be new work. It should be work that they're already doing. So a lot of times for kids who have math homework and they really don't like it, could mean that they might be struggling in some mathematics concepts. So if we can get to figuring out what it is that they might need support with, that will help. The other part is really thinking about how to utilize that homework and make it fun. I something I always say is math should be fun, and if it's not, we're doing it wrong. So really kind of leveraging that idea of why we're doing this math, and that's a big part too that Kelly was talking about is it's important to know why we're doing the math. So really getting your teenager thinking about what's the purpose behind this math homework and what might I need to support me to understand it as we kind of move forward. Another question or comment someone put in is they talked about Khan Academy and is really modern mirrors this current method for teaching mathematics. Absolutely. Khan Academy is a free website, um, and it's an excellent place and an excellent resource for teachers and parents to go to support their kids. Matter of fact, both my children use Khan Academy outside of their regular class too. So that is another resource that's available that you can use.
Yeah, so I also see in the chat that cooking using sometimes scaling recipes up or down. What if I needed to make, eggs for 5 batches or cookies or six cookies? Or what if we have, we're baking for your class and we have 40 muffins and we want to, share them evenly. What would that look like? Absolutely. We're going to talk about that. And those are some definitely great opportunities within context to talk to your kids about that. Yeah. So when we think about this idea that math is everywhere around us, and as a caregiver, you can think about how can we mathematize our spaces? How can we look at the world around us and see opportunities to notice math? And I think even after today, just really challenging yourself, like in my world around me, where am I seeing math? How can I call that out to my students and help them kind of see it with me? So we're going to talk about mathematizing your spaces a little bit. So participants just mentioned math in your kitchen. Really, really powerful, right? Whether you are working with fractions and you're using ingredients, whether you're seeing how many is left. And I think the really great part about math in our world is that you can scale the questions to what your student needs, right? So if let's say you have this picture of a carton of eggs, with a younger student in first or second grade, you might say, how many eggs do we have? How many did we eat? How many eggs are there all together? For our students that are in third grade that are starting to learn about multiplication, we can say, if it makes 2 eggs to make 1 batch of cookies, how many eggs do we need for 5 batches? Do we have enough eggs? And if your student's a little bit older and they're really getting into kind of that fractions, 4th, 5th, 6th grade, well, what fraction of this carton is left? What fraction have we eaten? What fraction is left? So you can really think about scaling your questions to meet your students' needs and where they are, especially if you're working, if you have multiple students. Excuse me. Another example we might see is when we're sorting, recycling, and trash, when we're playing or kind of designing something with cars, when we're measuring height. So again, with these potential questions, you might say, well, how tall is your brother in inches and centimeters? What is the difference in your heights? How much taller is he or shorter? And then even saying like, okay, when we go to King's Dominion, this is the height that you have to be on to go on the ride. Can you go on it? How much taller do you have to be? So really thinking about not just with numbers or the visuals you see with numbers, but also How do you see math all around you when you do everyday things like measure the height of your children? Math and our food. So when you have those younger children, some children might say, well, I think that sister has more than me, right? Because the configuration looks different. But when you actually look at it, they have the same. Asking questions like that, excuse me, who has more, who has less? How do you know they have the same, right? Really powerful. Another thing you can do, which is one of my favorite things to do, is just when you see an image, ask kids, what do you notice and what do you wonder? If you showed your kids this image of the watermelons, what do you think are some things that they could say, or what are some things that you notice? If I asked you to look at this picture, what are some things that you notice and wonder? And when you're ready, you can just go ahead and type in the chat. Oh, yeah, you see some fractions. Interesting. What else do you all notice and wonder? Who can build off of what she said, what Leslie said? What do we notice about fractions? Oh, that they're equal parts, that they're pieces of a whole. Yeah, that they're divided in pieces. So it makes you think about fractions.
The
The
idea of a
necessary.
denominator.
Mhm.
Yeah.
Yeah, so how many ways do I need to split it? I need to split it, 6 ways because there's 6 people in my family. You all are mentioning some very important ideas, right? And so when we ask students this, you might say, huh, so you notice that it's split 8 ways. Why do you think it was cut into 8 equal pieces? Huh, yeah, we call that a denominator. Well, what do you notice about all of these watermelons? What pieces are the same? What pieces are different, right? Kids love being asked what they notice and wonder. And they might even say, I notice it's red. I notice it's a watermelon. All of those are great. And then you can say, well, what math noticings or wonderings do you have? And sometimes it even leads to solving a question. Like kids might say, well, I wonder if the 2 pieces in the left equal the 1 piece on the bottom left. Like, are those the same? And then we can explore it and explore questions together. So one of the most powerful things you can do when you see images, or you encounter math at home or in your world, is just ask kids, what do you notice and what do you wonder? And then kind of pull out that math and ask them some more questions. Kids love being asked these questions, especially when the images are intentional and rich and they can talk about them. So it's one of the best things you can kind of do at home, again, without necessarily putting pressure on students, but just making it fun and something that they can notice and connect in their real world. Students might see math in their environment, right? How deep do we need to dig this hole to plant this plant? Thank you, Adam. Yeah, I know. There's going to be a bunch of things that come up and you're like, not quite a math idea yet, but thank you for your connection. They're going to see math in the environment, right? And patterns. They're going to see math everywhere. They might sort rocks. Which rocks are big? Which rocks are small? How can we sort by color? How can we sort by shape, right? So just encouraging that as much as possible. The last thing I kind of want to do is talk about math in context, right? So there are some ways between primary and then our older students towards the upper elementary grades that we can talk about math in context and through like looking at books, for example. So when we're reading books with our students, we can call attention to certain mathematical ideas. So patterns, if we're reading Brown Bear and you're thinking about the sequences that follow a rule, what patterns do you see? What patterns in his sweater? What patterns do you see in the environment? What do you see? How could you extend that pattern? How could you make the same pattern using something else? Spatial relationships. What happened first and what happened next? I noticed the blue dots are above the purple dot. The purple dot is below the blue dots. I noticed that there are circles in that book. There are triangles, right? Like getting the spatial relationships are really helpful in some of those primary standards as well. So for example, in a classic such as That's Not My Snowman, we might notice, I wonder how many buttons does he have? What do you notice about this picture, right? And really starting to talk about the book and what you see. What do you notice about his scarf? Does his scarf follow a pattern? What else do you notice? I see 2 buttons in that picture. Do you see anything else that has 2? Oh yeah, he has 2 arms, 2 eyes, right? So just kind of engaging with your students and what they're noticing in a book and how it's connected to math. If you have an older student, right? Our kids don't like see money anymore like they used to, all the coins and things like that. But they do understand that they're saving to buy something or that they want something, right? So maybe they're saving money to buy an Xbox and they just got $100 on their birthday and maybe they're earning chores with you each week. When can they buy it? Now, of course, this context has to match your family and what's happening, right? But engaging your kids in the problem solving and investing them in things that they care about. So this is just one example, but you might have some others that are more relevant to your family. Sports. This is new to me, but I'm learning all about sports with my son. So you might be talking to your students about their batting average. Okay, so-and-so has this batting average. How can we increase it? What do we need to do? What is that a good batting average? Is that a bad batting average, right? 264 thousandths. They're really starting to understand decimals and place value and how you get that, right? Something for more of the younger students, if they see a scoreboard and it's 13-6 or 21-7, oh man, we missed the game, but here's the scoreboard. What are the different combinations of the ways they could have scored in football, right? So now you're getting again to those equal groups, to combinations, to adding and subtracting. So really powerful if your student does like sports, how you can connect it to some of those ways in the real world as well. And again, these are just a few examples. You might have totally different examples if your student likes to run track or if your student is into other things, how you might connect math in their real world context and things that they enjoy. There are some wonderful books that our students can read from a variety of ages that supports this idea of a positive math identity and how children, like for example, with Miriam's magic, at first, she's a brilliant mathematician, but in school, she had a really hard time with math. And then she had this turning point where it all turned around and she had a beautiful experience and she was a famous mathematician, right? So exposing your students to characters that they can relate to that had their own journey with math can help them reflect. Well, what does that make you think? Where are you learning about Miriam's, journey and how she felt about math, right? So there's also on that resource a whole list of books and then an additional website. I love going to the library because I'm always looking for different books. So please feel free to utilize your school library or your community library. But these are some really powerful ways that we can not just talk about math in context, but talk about what math is and developing a love of math as well. Spencer, is there anything you want to add that I might be missing in context here? Anything about math and context that you wanted to add on to make this better?
No, Kelly, I think you really talked a lot about that idea of math and context. And that's really where our students, your children really make that connection to math is more than just something I do in school. It's something I do for my entire life. So the more that we can identify where math is in the real world, and that's what real math is, and that's what we're really trying to teach in schools, like the difference between real math and just doing a bunch of computation. Computation is important, but figuring out where does this math fit in real life. And I think that's a big piece that we're really trying to focus on in Fairfax County.
Yes, thank you, Spencer. Thank you so much. So as caregivers, you have so much potential to support your students in promoting a math identity and really thinking about like what are the ways that I'm talking about myself in math, that I'm thinking about a growth mindset. How can I support my students in a growth mindset? And that if we're persevering and problem solving, we can work hard to figure this out together. We'll make math, how can we make math joyful and fun based on what we see around us? And looking for opportunities and talking about math in our world, whether it's a book that we read, whether it's an image that we see, to really support that, and then to encourage our curiosity. I notice, I wonder what would happen if, right, getting your kids really kind of engaged in it with curiosity. So that's kind of how you can support your students in developing kind of that joy and love of math at home. I would like to invite you of like, what are some ideas you heard today? How might you engage with your students moving forward? Is there a small idea that you've heard that you might want to try? Or is there an idea about math in the real world or noticing and enjoying math that hasn't been shared that you'd like to share? So I'll just open that up to the chat for a couple minutes as you think about this reflection question. Thank you. Games, observing, picture books, definitely. And there are games, like I said, on the handout you're going to get, there are some games kind of listed that are, you know, free, easy, printable. And then of course, just the board games you play and thinking about where are opportunities to ask about where kids see math in that. Absolutely. Yeah. Using that vocabulary, absolutely. Just having some questions. How many do you see? How do you see them? What do you notice? What do you wonder? Are all things that can be really helpful. There were some questions about finding like what are my students learning in their grade level. And if you want to find that, you can go to scaps.edu/academic/elementary. You would click on your student's grade level, and then you click on something called the program of studies. And then you can see a very basic kind of outline of the standards. Now keep in mind that the math standards that students get are from the Virginia Department of Education, but the program of studies also includes some additional opportunities for enrichment from Fairfax County as well. So you can kind of see what your kids are learning, if that's helpful, if you're thinking about what questions you want to ask them and how you want to support them. That the grade level program of studies is also linked in that resource handout in case you don't want to follow these steps. Everything we talked about today and more is included on that handout. Thank you. Yes, I can absolutely relate to that. Like being a full-time working parent is something special. It's really hard, but sometimes just stopping and being like, you know, my toddler is collecting leaves and I'm like, what do you notice? And he's like, well, these are red and these are brown. Like, okay, great, you're sorting them. What else can we do? And it's like, I don't even recognize it, but we're preparing him to love math and to understand math as they get into kindergarten and beyond. Yeah. Thank you so much. I'm going to stick around here because we do have a little bit more time. If there's anything that you need, I believe there was a survey put into the chat. You will be given all of these resources, and I just thank you so much for your time today.
Okay, thank you so much. And we will be sending out we'll be sending out the PowerPoint to you all, in addition to posting the recording on YouTube. And so please reach out to us if you have any questions. We thank you all for being here today. Kelly, did you want to hang on, or are we good?
It's up to you. I'm happy to if you'd like me to. I have a couple minutes, or but I think